Thanks. Good afternoon. This is the final talk of the conference, and the idea is to give you a framework to think about the future of blockchain with some inspiration from other models. And so blockchains are like biology in that there's similarities that insights from biology can give you insights into how blockchains are likely to evolve in the future and a little different perspective on how they work in context. And so blockchains brought to the internet a new protocol, and the new protocol that blockchain adds to the internet allows a few things that have been left out of internet standard protocols that can now be done. The four that are most important is identity that is secure, trust between transaction parties, and those two allow you to do money. And then the fourth is a ledger of accounting that is the truth that all the parties participating at the time agreed on. And then that is preserved long term, so you can look back and see, well, what is it that people agreed on? And so most of you, I'm sure, are familiar with double entry accounting, and this was something invented about 500 years ago as a way to keep track of money between parties. And essentially there's the debits and credits ledgers, and that each person takes accounting from their point of view. And if the totals of the debits don't equal the totals of the credits, there's an error somewhere in the history, and it's a way to go back and find it. And what blockchain gives us is triple entry accounting, if you will, where there's still the two parties and their own internal accounting that they can reconcile. And there's a third accounting, which is the public accounting, if you choose to make it public, which is the record of that both parties agreed, and then that record is saved and accessible to everybody to review. And so essentially it's the truth, and it's a truth that is distributed not just on one computer, but on thousands of computers that are the nodes. And so even if it were to be modified on one computer, the other computers would not have consensus about that, and that modification would be at least logged, if not rejected. And so blockchain is a store of information, just like DNA. And a human genome is about 1.5 gigabytes in a computer, and blockchain's database currently is about 150 gigabytes, so a lot more data on the blockchain already than in the human genome. And the graph on the left is the red mark is when blockchain passed the human genome in size, about 2012, and it's growing exponentially by a mathematical formula that a block is written about every 10 minutes. If it happens faster, the algorithms get more difficult to slow down, and if it happens slower, the algorithms get simpler to speed it up. And so you can predict on the graph on the right for 100 years in the future what it is likely to be in the size of the blockchain over time, where reaching about 250 gigabytes at the end of this year and a terabyte in 3 or 4 years. And so blockchains have some characteristics that people commonly describe, in that they're decentralized, in that they're not on one computer or one place. It's distributed around the internet. It's borderless, in that there isn't a limit between nation-state borders. It's a replicating database that replicates across time. It's a data framework, and it's a protocol. And so what other things are kind of like that is genetics, and the information stored in DNA, and that it's also decentralized. There isn't a central store of genomes. It's distributed in that creatures live all around the world. And it's borderless in that creatures don't recognize national borders necessarily. And it's a replicating database in that genetics replicates with each generation. It's also a framework for storing genes that make metabolism, and it's a protocol for how the data is stored in this molecular format. And so there's some similarities that go further in that the center graph is the amount of energy it's been taking to mine Bitcoin's blockchain. And the energy to do that computation is coming from electricity. And the computation machinery is getting better and better with ASICs and such. But the compute power needed to write a block is going up super exponentially. And so the moving information on blockchain or metabolism on blockchain is something that consumes electric energy. In biology, what's needed to replicate DNA is also energy, and it either comes from photosynthesis in plants or from predation or food in animals. And that you have to eat life to live, and that life that you're eating is providing energy that is used for your own metabolism and replication. And so there's different kinds of species evolved in biology to make better or lesser use of energy for different niches. And the premise is that different species of blockchains are evolving that also make different uses of the amount of energy they consume and have different characteristics, just like different species. So if you were to step on a petri dish with your shoe and let what's there grow, you would find many different diverse species that were living on the ground that grow, and they have they're based on DNA, but they have different characteristics and different information in them. And so the equivalent of that in blockchain is there's about 2,000 different species of blockchains now. These are the tokens that have issued in the last 2 years. And they're exponentially increasing the number of different kinds of tokens and underlying blockchains that each have different characteristics. That maybe it's faster, or it's more secure, it's more energy efficient, it has governance, or it has other properties that make it better suited for certain kinds of applications than others. And so the flow of information in biology goes from the parent's DNA to RNA to proteins to metabolism. And so the flow of life, or our experience of life, is the information that's on our genome that is being metabolized over time. And there's a similar characteristic in blockchain where the metabolism of a blockchain is the tokens that flow across time in the records of the block transactions that are being written. And there's other parallels in that blockchain has the tokens, as I just mentioned, and distributed apps that run on top of those tokens, and you can build distributed organizations out of these distributed apps, and in a sort of like an ecosystem. Genomes have metabolism and ecosystems as well, and then just as animals speciate into, for example, horses and donkeys, blockchains can speciate into different versions, and this is called forking in the blockchain parlance. And so Bitcoin's blockchain forked into several different species, like Bitcoin Cash, as examples, that are different creatures then. And these different creatures are subject to natural selection based on their properties, and some will survive, and some will have to find a specialized niche, or they go extinct. And the question comes up that's important is, are blockchains going to converge on some standardized protocol blockchain like the internet standardized on TCP/IP, or are they going to diverge into many different species of blockchains, like the number of apps or the number of websites? And so if they were to standardize into one particular protocol that might be well designed for one kind of application, or maybe many, it creates a vulnerability in the stability of the ecosystem. And that a prominent ethnobotanist named Schultes has a concept that monoculture breeds disease, or it makes the ecosystem brittle. And so monoculture is where all the creatures are clones of each other, such as in potatoes or corn or bananas. And if they're all clones, a parasite can evolve that will exploit the deficiency in that particular clone. And the vulnerability is it wipes out all of them very rapidly, where if there was a diversity, it would only wipe out certain ones. And so one of the characteristics of blockchains are regulation is coming, and the blockchains that are issuing tokens that are issued as securities are more or less in compliance with the regulation. And those blockchains that are telling a different story are at risk of being regulated. And so the regulators are looking at the traditional history of what is a security, what is a security offering, and those blockchains, the SEC just made comments in the last week or so of Bitcoin and Ethereum are currencies and not securities. And they made a sort of side comment that even if somebody were to design a perfect utility token in every way, if they marketed it as an investment, it would be deemed a security offering or security marketing, and thus subject to securities laws as essentially a stock. And so even if something is designed as a utility token, it doesn't mean it won't be subject to securities regulation laws in the US and China, and as we've heard about at this conference. And so the protection against monoculture and something getting wiped out as a species. So for example, if regulation were to attack your particular token or your particular blockchain, it would easily be wiped out and go extinct, while others maybe will survive. So what's happened in biology is you have many different kinds of species or creatures, like microbes and plants and animals and so forth. And these have evolved from a common ancestor. And so about 4 billion years ago, there was original DNA life on this planet, and it's diverged or forked into many different species. So this is a graph of all the different species that have emerged across 4 billion years. And there are millions and millions of different species, but everybody is related to each other through the DNA. And so essentially we're all cousins with the plants and the animals and the fungi and the microbes and so forth. And the blockchains are very likely to go through a similar kind of evolution into many different ones, where if you want one that's better for paying parking meters, it's faster, or if you want one that's more secure or more energy efficient, you can design that as a different species of blockchain. And so what happened in biology about 500 million years ago was the Cambrian explosion, where a small number of blockchains diversified rapidly into 3.5 million different species. And that's happened in biology around the time eyes were invented. And so there may be a future as yet invented in blockchains that will be invented that will create a Cambrian explosion type of change in the number of different blockchains that you can choose from. And so in the further future, our life as we experience it is originally coded in DNA, and most creatures, that's most of the information of their life. But in humans, we learn a lot of the information that becomes part of us. So it's all that we eat and all that we experience and what we remember. And so with the emergence of the internet and culture and storage of this in digital form, what defines me as a person isn't just my DNA anymore, or even the chemicals in my body. It's the information that I've learned over my life. And this is traditionally stored in my memory, but increasingly it's stored in the internet. So we have our medical records, but also our credit report and our Facebook history and all of our footprints on the internet that is growing at exponential pace, and more or less people are comfortable sharing twice as much information each year as the year before. And so the amount of information that we're sharing in a digital form is increasing at a doubling rate per year, and that shows no sign of slowing down. And so the amount of information that defines a person has changed from mostly chemical to mostly digital. And the digital is growing much faster than the chemical, and that's partly because computers can save and replicate information much better than biochemistry, at least 1 million times more accurately. And that genetics or the DNA replication makes an error about every 1 in a billion pieces of information when it's replicating, when it's copying, where computers are at least 1 million times better than that. So the amount of information saved that defines a person will be much more than the biochemistry in the further future. And so basically, we as humans have become mostly information, and that information isn't static. It's not just what is the chemical composition and the things I've learned at this moment, but it flows across time, in that our life isn't the information in us, it's the flow of information that we experience. And so, in a sense, we're surfing on an information wave, in that our life experience is how the information changes in our body. And so, tokens have a similar kind of property, in that the experience of a token over time is its flow across a blockchain. And so, in a sense, again, a blockchain is a bit like a genome, and humans are a bit like tokens on the genome of humans. And so that's our experience of how life moves in time. And so there we have essentially blockchains being like biology, and how you can anticipate some of the future of blockchains from some of the history of biology. So with that, any questions? Questions? Objections?
Obviously, it's an excellent analogy, but what would you say would be the top difference?
Well, some differences are blockchains, most of them save every single transaction since the genesis block of each one, or the fork of each one. And genetics doesn't do that. Genetics throws away a lot of information, because it's too energy inefficient to copy every single historical transaction in genetics. And that's a difference that maybe blockchain remembering more will evolve away, in the same way as genetics chooses some information to throw away and some to keep. Maybe the surviving blockchains will do similar, but none do that today, as far as I know. That's one difference.
When do you think it is the singularity of the blockchain and AI?
So the term singularity basically means change, in that changing from a predictable model of what's happening into an unpredictable model. And so it originally comes from physics, and was originally coined as the event horizon of falling into a black hole, where regular Newtonian physics works when you're out far from the black hole, but as soon as you fall over the event horizon, called a singularity, what happens when you fall into the black hole becomes unpredictable. And so the technological singularity is a term that has come recently from what happens when AI becomes smarter than people, and that when the internet is more intelligent than people, or all people. And the basic use of the term singularity is saying how society works, how people survive, will change into an unpredictable state, but what state that is isn't known. In the same way as falling into a black hole, what happens isn't known. And so the concept of a change from regular expected biology, or regular expected computation of intelligent systems will the balance of power, if you will, in intelligence is shifting as the internet gets smarter and AI gets smarter and machine learning. And so a time is coming, or it's partly here, that computers and the internet are way better at doing certain things than people, and a time will likely come where they're better at doing everything than people, except maybe mating with you. And so that's an unpredictable change. And so blockchain is a part of that larger picture of the information changing from biochemistry into electronic form, and then evolving into smarter and smarter electronic forms that may someday be smarter than the biological creatures. And so if you want to participate in that, copy more of yourself into the internet, because that's the information that AIs learn from. And so if you have more information there to learn from, the AIs will be able to reconstruct you more accurately than if there's less information there. So it's a reason to share more rather than less. Does that answer your question? Any other questions?
What role does privacy play in the future?
Well, in my opinion, privacy is an illusion in that we think we have privacy, but it's relatively easy to detect many things about a person that without their knowledge. For example, our credit reports in the US or in China aren't something that you opt into or sign up for or agree to the terms of service of. These are information that's collected by other entities about each of us, and that information isn't with our permission, and in many cases, the information is we don't even know what it is about us. And so that information can be accessed in many ways from the internet side to understand more about a person than they think the others know. And there's a Jungian concept of shadow self, of how you maybe see parts of me that I'm unaware of, and the internet sees parts of us that we're not aware that it's even seeing. And what is used for that, it could be used for good or for bad. Like, for example, you can predict a heart attack based on changes in people's social media posting weeks or months in advance of it happening, in that people's tweets become more aggressive with more swear words and so forth in the time leading up to their heart attack. And they're completely unaware of that. The AI analyzing each of our histories can learn to detect that. And we may think our impending heart attack is private, but it's actually pretty visible in the outside. And so is that kind of what you meant by privacy? So from a personal point of view, you can choose to keep more of your information private or more of it public. And if you look at the evolution of culture, it may pattern the evolution of single-cell to multi-cell organisms. And so the cells in our body have very limited privacy, in that from the outside, all the other cells in our immune system knows what each cell is doing, and if it's misbehaving, it gets eliminated. And if it's behaving well, it gets more nourishment. And so it may be that culture is evolving in this way, and what's happening outside of us, or outside of our interior thoughts, is public, or in a way that the immune system and the internet of society can detect it, even if we try to conceal it. And maybe just our interior thoughts will be private. But there's even technology advancing very quickly to read interior thoughts from brain imaging systems to anticipate what people are thinking. And then with machine learning, you can use the past of what somebody's behavior and thinking has been to model their self to predict what they're likely to do in the future. And we do this as humans in psychology all the time, where we have what's called a theory of mind, where you may have a concept in your mind of me already, of course, and you can decide what I'm likely to do next based on your theory of what I'm likely to do next. And humans are actually pretty good at that and pretty accurate, but computers are getting better at that too. So both the external self is not very private, and the interior self is becoming less private.
Hi,
Well, blockchain creates a way that you can kind of authenticate the parties involved in a transaction, and you create an auditable, unchangeable history that those parties agreed on something in the past. And so you're not only modeling each individual, but you're modeling the interactions between individual, and blockchain is the record of that. That is stored, it's not always public, like hyperledgers aren't always public, but Bitcoin's blockchain is fully public, so is Ethereum, that everybody can see today's transactions, but all of the transactions going back 10 years on it. And so the combination of who are the parties transacting, which might be encrypted, they might be hashes, but the transaction is done when those parties agree to the result is written into the blockchain, and that blockchain is permanent. So machine learning systems can pay attention to this public data and will figure out patterns of your wallet doing transactions over time, and from that alone can probably predict who you are as a biological person based on your transaction behavior over time gleaned from the blockchain. So machine learning will be able to mine this data not just for the transaction history, but using it to identify who the parties are and the financial interactions, and then mine other data like cell phone records or social media or internet and public records to build a very complete model of each person, and not just the history of what they've done, but with machine learning you can model who they are and what they're likely to do in the future. And that's coming very fast. It's already affecting choices of ads and voting and choices of food and things of that nature.
Thank you. Very good.
Other questions? Okay. Great. Thank you so much.